Morning, everybody. Before we get started in our usual lecture here, I want to go ahead and do this problem that's on the screen now here regarding general form. I did send you all an email about that, but some people just prefer it better if I show an example. And so I'm going to go ahead and show this example. Also, the email that I sent you yesterday, I incorrectly said that we're going to be doing 1.5, and that's wrong because 1.5 doesn't actually exist in this course at all. It's going to be 2.1 instead. So 2.1 is what we're going to start today. And that also is the one that's already been opened that you can start working on. So we're going to do 2.1 today, and then we will continue. Let's see how much of that we can get done. So that's the one that's not due until next Sunday. This Sunday is 1.1 through 1.4 only. So we will go ahead and continue with this problem that we will do here. And this is one from the homework. Write the standard form and general form for a circle with a radius of 3 and a center of 7, 1. So this kind of problem, again, this is from 1.4 is where this problem is actually from. So we'll take a look at this first before moving on to 2.1. So circle with a radius of 3 and a center of 7, 1. We were doing these kind of problems yesterday, but just to review, this is the main formula we're going to be working with here. So we've got the x minus h squared, y minus k squared equals r squared. This is the standard form, so that's the first answer you're going to do there. So we're going to do x minus, so we have, this is h and k that was given. So h is going to be 7. And then we have y minus 1 squared, and that equals r squared, or 3 squared, just like that. And so then if we simplify that further, we get a 9 here. So this is going to be the standard form answer right there. And then the next thing it asks us to do is find the general form. Now, general form was not something I talked about yesterday, so I want to go ahead and mention it here. Basically, all standard form is you've got everything is all set equal to 0. So for general form, we'll just put that here, general form. Basically, it goes like this: ax squared plus by squared plus cx plus dy plus e equals 0. This is what the general form is. You have to start with the squares, so x squared and y squared on that you have, and then then we just have regular x and a y and an e. And so this is what we call standard general form, is what that is. So we did some problems yesterday where we had a problem started out in general form, and then we had to find the center and the radius. So this is actually going in reverse. We're starting with the center and the radius, and we're working our way back to general form. Now, the way that you're going to do this is you're going to take the standard form and you're going to square everything all out. You're going to distribute everything on that and get it to look like this, where we have x squared and y squared that comes first. So that's what you want to do on this kind of problem. So I'm going to take this. Now remember that we have really x minus 7 times x minus 7 there because it's squared. And then I have the y minus 1 and y minus 1. That's squared, not squared, just 2 of them. And that equals 9. And then we're going to continue with this and multiply out. So I'm running it out this way just to remind us that we can't take the square and square the x and square the 7. So if you weren't getting this problem right, that's probably one of the reasons why. So let's take a look at this part down below here. We're going to do x squared. Then we have minus 7x minus 7 is minus 14x plus 49. So we're doing a FOIL on that. We're going to do this one too, y squared. And we have minus y, that's a minus 2y, and then plus 1 equals 9. So we've expanded it, but we need to put it into this form where the squares come first. So in this case, we've got x squared plus y squared. We're going to have that one go first out there. And then next we have the x and the y terms. Now there's no like terms with these, so I'm going to do minus 14x minus 2y we have there. And then we have a plus 50. 49 and 1 gives you 50 there. Okay. The last step is we're going to subtract the 9 and get it to look that way. We can have it looking like that form right there. So we're going to have x squared plus y squared minus 14x minus 2y. If we subtract that over 50 minus 9 is going to give you 41. And so that right there, this is the general form. Okay, so now we have standard form and we have general form. So now with that, you should be able to do the homework questions that are in there. There's a couple of them that ask you to put something in standard form and general form, and then they want you to graph it afterwards as well. And so that I just wanted to go over one example for you, since I did have a few people ask about that. And so that would be your answer on that one. Okay, so that's how you want to do that one. Again, this is general form. We didn't talk about this yesterday, so I wanted to talk about it today before we go on to the next section. So with that, now we have notes from 1.1 to 1.4, so you're only responsible for notes from 1.1 to 1.4. That's to be due this week. Next week is when, next Sunday, a week from Sunday, is when the 2.1 section is going to be done. But we're going to go ahead and start on that today, so that way we don't have as much to do for next week. So what I'm going to show today in 2.1, that will be open for you. That assignment's already open, but you'll notice that the due date is not until next week. By the way, also, you're going to find section 2.1 in next week's folder in My Open Math. And so will see each week, the only assignments that are due that particular week are going to appear in that folder. So if you want to work ahead, then you'll have to look at next week's folder when you do that. As I mentioned yesterday, if you'd like to work ahead, please feel free to send me an email, and I'd be happy to open up an assignment early for you if you want to get started on it. But this one, 2.1, is going to be already open for you. So we're going to go ahead and do this section today. We may finish it, but we'll just see how much we get done. Again, whatever it is, it won't be due until a week from Sunday is when this assignment will be due. All right, so 2.1 functions. We've got a couple definitions up front first. So first of all, we've got domain. The domain is considered like an input. It's like an x. It's all the x values that make a function defined. And so I need to talk about what define means. So define means that there's no division by 0 or square roots of negative numbers. So essentially, what you're trying to find with domain is you're trying to find all the values for x that a function is going to use where it doesn't cause division by 0 or square root of negative number. That's basically what we mean by defined. Then we also have range. Range is the output. That's all of the y values that the graph uses. So you'll put some stuff in for x, then you'll get all the different y values the graph uses. That's called the range. And so that leads us up to what a definition of a function is. Okay, so this section is called functions. Function means for every input x, there can only be one output y. So you put one number in, you get one number out only. If there's a certain x value that causes more than one y value, that means you do not have a function in that case. We're going to take a look at several different ways to determine a function. We're going to look at a set of points that we have down here. We're also going to look at a graph. We're going to look at the equation, and that's going to allow us to know whether we have a function or not. So we're going to take a look at this particular example here. We have lists of points. So if you have a set of points, that's called a relation. So that's basically what we have down here. So for each of these relations, they're just basically a set of points. We want to determine which one is a function, and then it says give the domain and range for each relation. All right, so first of all, what we want to do to determine it's a function or not is we're going to look at each x value, and each x value should go to only one y value. So I have 1 goes to 2, 3 goes to 7, 2 goes to 9, 8 goes to 11. All those x values, they all go to its own y value. So I know for sure that this one is going to be considered a function. Okay, so for sure that's a function there. But now they want us to determine the domain and range for each relation. Okay, so the domain is just going to be all the x values that you see here. So I'm going to write that as a set. So I have 1, 2, 3, and 8. I'm just listing, all I'm doing here is I'm listing the x values only from here. So that's the x values of these coordinates that we see. Okay, so that's going to be the domain. Now the range is going to be all of the y values that this uses. So 2, 7, 9, and 11. 2, 7, 9, and 11. Those are just all the y values. So domain is all the x values of the coordinates. The range is all the y values of the coordinates, and that's all they want you to do on that particular question there. So we're going to do kind of keep on going with these other ones that we have here. All right, so first of all, this one we have to determine if it's a function or not. We have 3 goes to 4, 5 goes to 6, 7 goes to 4, and -2 goes to 3. Now notice that we do have two of these points, -3 goes to 4 and 7 goes to 4. Okay, now even though both of these go to the same y value, this is still going to be considered a function. Now the reason why is, remember, the definition for a function is every value of x has to go to only one value for y. It just so happens that the one value for y is the same for both -3 and 7, but the definition for a function still holds. I have -3 only goes to 4, and I don't have -3 going to anything else. 7 goes to 4, but 7 does not go to any other number. So again, I have one input, one output. Okay, it's okay if the output happens to be the same like it is here, but it's still a function because every input has only one output. For all these points here, we have that. So for your domain, it's going to be all the x values that this uses. So it's going to be, you don't have to put them in order. I usually do put them in order from smallest to largest, but you don't have to. If you put that in my open math, it'll still accept it. Okay, so -3, -2, 5, and 7 we have for that. Those are just all the x values that this is using. Then the range, R for range, is going to be all the y values. Okay, now if one is repeated like this, you only have to list it once. So I have, that look like a little bit better set symbol here. Okay, so I have 3 comes first, and then 4 is repeated, but I'm only going to write it once. And then I have 6. Okay, so I have a 3, a 4, and a 6. Those are all the y values that this is using. And then that's all you have to put on that one. Okay, now the next one. Take a look at these 2 points right here, -2, 4, and -2, 8. Notice in this case that I have a -2 that goes to 4, but I also have a -2 that goes to 8. So in this case, I have the same x value is giving me 2 different y values. So because of that, we have to say that this is not a function here. And it's not a function because I have the same x value is giving me 2 different outputs, 2 different y values. So that's why it's not a function there in that case. I'm going to write the domain and the range again. Okay, so domain is all the x values that we see. Again, -2 is listed twice, but we only have to just put it down once here. -1 and 0. Okay, so the repeated ones we only write once. We have that. For the range, it's all of the y values. So I have a 3, a 4, 6, and 8. Okay, so 3, 4, 6, 8 I have for the y values. Okay, so that would be domain and range. Now here's the last one of this type that we're going to do, and then we'll move on to the graphs. Okay, I have 5, 3, and 5, 3. So I do see that I have an x value that is repeated here. However, this is okay because it's just giving me the same information twice. So this extra 5, 3, we could pretty much just ignore that one and just look at the remaining ones. So if I just look at these right here, every x value only goes to one y value. And so this is another one that's going to be considered to be a function. Okay, so again, even though I have 5 goes to 3 and then 5 goes to 3 again, it's repeating this information. Still, the x value of 5 only goes to 3. It's just that we're just reminded of it again the second time, but that still means the same thing. So that's a function. Domain, okay, is going to be the x values. So I have -2 is the smaller one, then I have a 5, and then I have a 9. Again, that's listed in order from smallest to largest. Again, you don't have to do that. You can just list them in any order, and my open math should take that as an answer, but I'll write them in order here for you. For the range, it's the y values. I have a 1, I have a 3, and I have a 10. I'm only if it gets repeated, I only write it once. So just 1, 3, and 10, those are the y values, and that's going to be your range. So that's the first type of question that you're going to have here, is you're going to have a list of relations, a list of points, and you're just going to determine that whether it's going to be a function or not. But the next type of problems that we're going to take a look at are going to be ones where we actually have a graph that's given. And so let's take a look at those questions. Let's take a look at this next. For graphs, we have something that's called the vertical line test. So you can go ahead and read that one there. So the way this works is if you pass an imaginary vertical line through the graph and it intersects the graph only once, then it's a function. So if anywhere on that graph you draw a vertical line and it hits the graph more than once, then that's telling you it's not going to be a function. Now, the reason why this actually works is because a vertical line represents one x value. So if that x value, if you hit the graph more than once, that's telling you that for that particular x value, you're getting more than one y value, and that means it's not a function. A function can only have one input, one output, one x value, and one y value only. So let's do the vertical line test for each of these right here. So now this one, I could draw a dotted line here. I could draw another dotted line down there. No matter where I draw it along here, even here, no matter where I draw the vertical line, it's every time I do that, it's only hitting the graph at one place. Okay, so this one right here, this is considered a function. Okay, so that's a function because for every x value, I'm only getting one y value there. Now let's take a look at the next one. If this one right here, if I draw a vertical line down through there, it's hitting the graph at two places. Now there is one case where I could draw a vertical line here, and that's only going to hit the graph once. But what you want to do is look at the entire graph. So if there's any other place where you draw a vertical line and hits the graph more than once, then that means it's not a function. So this one is not a function, because when I draw the line, it's hitting it in two places. That means that at this particular x value, let's say, for instance, -2, I'm going to get a y value up here and a y value down there. So I'm getting two y values for the x value of -2. That means it's not a function. Now let's look at this last one. Okay, so if I go down here, it only hits the graph once. It's only once there, only once here. So no matter where I draw a vertical line for this last example, I'm only hitting the graph in one place. So this is going to be a function. Okay, so it's a function because everywhere I draw that vertical line, I'm only hitting the graph in one location. So now that means that I have a function for the last one. So we've looked at relations so far. We've looked at the vertical line test. Now let's take a look at some equations here. Okay, so some equations we're going to look at next, and we're going to determine if the equation itself is a function or not. And that's what we're going to look at for these right here. Okay, what we're going to do for these equations is we're actually going to solve for y, and then we'll be able to determine from there if we get one or two y values. So let's take a look at this first one, and we're going to take this and we're going to solve for y squared, which means that we're going to subtract the x squared over to the other side. So we'll just move that across the equal sign and you get a minus. Then we want to divide everything by 3. So we'll just divide the whole thing by 3 there. And we get y squared equals negative x squared plus 7 over 3. We're not done yet because we got to solve for y itself. Now, because there's a square here, it means that we have to take the square root. And whenever you take a square root of something, remember you always get plus or minus. Every time you take a square root of something, no matter what it is, you always will get plus or minus. So I get plus or minus negative x squared plus 7 over 3. All right, so I have this. Now, if I take a look at that, already we can tell that we're going to be getting two different y values here. For instance, if I put a 0 in for x, for instance, I'm going to get plus or minus the square root of 7/3. That means that for the input of x, I'm getting two different values for y. So this right here is, we can say, is not a function. Again, the reason why is because of the plus minus here. Okay, so basically that part right there, the plus or minus, that's how you can tell it's not going to be a function, because the plus minus says we're getting two different y values for a single x value. We're going to do the same thing down below here. So we have x squared plus y to the 5th. So is that a function or not? So same thing, we're going to solve for y. So we're going to subtract x squared. So I have 1 minus x squared I can put there. So it becomes negative when I move it across the equal sign. Now this time I want to take the 5th root. Now because we're taking an odd root of something, that means we're just going to get the 5th root of 1 minus x squared, but this time we don't have plus or minus this time because we're taking an odd root. If you're taking an even root, you get plus or minus. If you're taking an odd root, you only get one answer on that. So for this, for instance, if I put a 0 in for x, I get the 5th root of 1, which is just 1. There's no plus or minus here. So in this case, this is going to be considered a function, because if I put a value in for x, I'm only going to get one value for y. There is no plus or minus on this one. So that tells us that that's going to be a function. So if you notice on this, we have kind of we can actually make a generalization with this that's going to allow you to solve some problems in the homework a lot easier than doing this. So the conclusion, we're actually going to have that right down below here. So here's the conclusion. Okay, any equation that has a y raised to an even power is not a function. Any equation that has y raised to an odd power is a function. So automatically, you can just look at the problem that's in my open math, and you can just answer that based on what the power of the y is. So if you see y raised to the first power, that means it's going to be a function, or y raised to any odd power, for instance, either y to the first power, y to the third, y to the 5th, and so forth. That's going to be a function. And if you see a problem where you have that y is raised to even power, that means it's not going to be a function. Okay. Now, other types of functions you might see anytime you see y by itself, y to the first power is equal to something, that's a function. Okay, so that's how you can tell the difference between those two when you work at and do the homework. We do have a function notation that we're going to talk about next. And so function notation, I mentioned this the other day when we talked about the graphs. You see this right here, an F with a parenthesis afterwards. It's pronounced like this, F of X. It does not mean multiplication, so we're not multiplying an F by an X. Doesn't mean that. What it does mean is that we have some equation that we're calling F, and it contains the variable X. That's basically what it means. So if I see whatever variable is inside the parentheses, that's the variable that should be appearing in the problem itself. So like this one down here, this example, if I have f of x equals 2x minus 5, so basically I have an equation, I'm calling it f. The variable that I have there is x, okay? So I've got an example here. These two things I want to solve for. I want to find f of 3, and then you also want to solve f of x equals 7. So we're going to kind of do both of those at once. If you have something like this, whatever thing that you see inside the parentheses goes in for the x that you have here. So if I want to find f of 3, this means that I'm going to take this x here and replace it with a 3. And I have minus 5. So whatever is in here is what goes inside here. So there's a 3 inside the x there. I'm putting a 3 inside the x here. So f of 3 equals 2 times 3 minus 5, or f of 3 is equal to 1, 6 minus 5. And that's it. That's the answer for the first part. So f of 3, again, you just put the number in for x. Now the other one is a little bit different because now we don't have a number inside the parentheses, so we do have to keep this as an x. But what this is saying is that you want to replace the entire f of x with a 7. That means that this is what this will look like. Okay, so originally I had f of x. I removed that and put a 7 in there. So this is kind of like a separate problem we're doing here. We're doing this second part. So put a 7 in for f of x, and then we want to solve for x. So we'll get an answer for x as a result here. So we're going to just add 5 to both sides. 12 equals 2x, divide both sides by 2. And we get a 6 for x. And that would answer the second part. So f of 3 is equal to 1. That's the answer there. For the second question, it says here, my answer is going to be 6. We're setting it equal to 7 there. Well, we're going to answer a couple more questions, still using the same f of x. Okay, so it says now, given the function f of x equals 2x minus 5, the same one we had before, now it's asking you to find f of x plus 3. This time, we're not going to be able to get a numerical answer for that one because we have an x that's still left inside the parentheses here. However, the process is still the same from the problem we did before where we want to find f of 3. So instead of putting in a number for this, I want to find f of x plus 3. That means that I'm going to put an x plus 3 in place of the x in the original equation. So I'm taking out the x, replacing it with whatever I have inside the parentheses here. So I have 2 times, normally it would be 2 times a blank because I would get rid of the x, replace the blank with x plus 3, and I get this. Now we're just going to simplify that, 2x plus 6 minus 5, and we get 2x plus 1. So this we can just carry this down here. So my final answer, f of x plus 3 is going to be equal to 2x plus 1. So again, we just take out the x here, replace it with what's inside the parentheses. This part C is a little bit different. We have an x and we have a 3 here, but it's different from what we had before. So they want you to write f of x, and then we're adding f of 3. Well, f of x is just the original one that we started with, 2x minus 5. And f of 3 is actually what we did on the up here. F of 3 is equal to 1. So we actually have both these pieces already. So let's write this out. F of x, we want to do f of x plus f of 3. F of x is this equation here, 2x minus 5. F of 3 from part A, we did that in part A, that was equal to 1. Again, where did I get f of 3 from? I got it from part A. We found f of 3, it's 1. So I just put that back in here. Then you're going to simplify it, and we get 2x minus 5 plus 1 is minus 4. So we can just write our answer like this: f of x plus f of 3 is equal to 2x minus 4. And that would be your answer on that one. We have f of x is equal to 2x minus 5. We want to find f of x plus h. Now this f of x plus h, that's actually something that we're going to be using a little bit later. You'll see a reason why later, where this f of x plus h comes from. This is actually part of something else called the difference quotient that we are going to be doing a little bit later. Okay, and that's going to be later in the section. We'll actually come to that. So, but first, we want to figure out just how to do what it's asking here. We want to find f of x plus h. What that means is that I'm going to take my original. Here's my original equation that I had. F of x is equal to 2x minus 5. So instead of the x, I'm gonna take out the x and leave a blank. The blank is going to get filled in with whatever you see here inside the parentheses. So that's going to be x plus h. I'm going to put in right there. So no matter what is inside this parenthesis, I'm just going to replace the x by whatever you have inside the parentheses there. Let's simplify it. We can multiply the 2 and get 2x plus 2h minus 5. Now that's as far as that we can go with our answer on this, because none of those are like terms. So 2x and 2h and 5, none of those are like terms. So that's going to be that's all I can do on that. I don't know what x is. I don't know what h is. So I can't get a numerical answer on that one. I'll just leave my answer as that. Let's do one more, or two more actually, two more with this same f of x that we have here. So we're going to do e and f. Okay. Now these are it's going to ask you all these similar parts when you do these kind of problems in my open math. And so it's going to ask you a similar question on that by writing all that down. So let's go ahead and now jump to do these two. Now these two have a negative, there's inside the parentheses, and there's a negative outside. So these are actually done differently on that. So first of all, f of negative x. That means that you're going to replace the x here with what's inside the parentheses. Okay, so we've got f of negative x is equal to 2 times negative x, then minus 5. So if I simplify this, it means I get negative 2x minus 5. And then nothing more I can do with that because I don't know what x is. And so then I'm just going to leave it as that point. It's just an equation just like that. So nothing else I can do. For f, what this means right here is this here means the same thing as negative 1 times f of x. That's what that notation means. So negative f of x is negative 1 times f of x. So essentially, if I want to do negative f of x, this is equal to negative 1 times the whole entire quantity, 2x minus 5. So that's all I'm doing there is multiplying the whole thing by a negative 1, which means that if I multiply that through, I get negative 2x and then plus 5. And then that would be it. That's your answer for that particular one. All right. Okay, so we have that one. So now that's everything we have complete for that. Okay. All right, so moving on, we're going to do some more things where we're evaluating, but now we're going to take a look at a rational function. And again, we're going to go ahead and run through some of these type of questions here. We got kind of the same ones as before. So let's go ahead and take a look at this right here. All right, so we want to find f of 5. So we're going to so this time we have an x on top and x on the bottom. So when you're trying to find out f of 5, that means that both of these x's are going to get replaced with a 5. All right, so that's going to look like this. So f of 5 is equal to 5 minus 4 over 2 times 5 minus 3. And we're going to get 1/7 as a result there. We get 1 on top and we get 10 minus 3 or 7 on the bottom. And that's going to be your answer. So f of 5 is equal to 1/7. Part B, we have another one of these f of x plus h things going on again right there. So we're going to go ahead and put in x plus h, both places where you see an x up here. So f of x plus h, we're going to put in, so on top we've got an x minus 4. And the bottom we have 2 times a blank and then minus 3. So I basically just took the original problem and just took out the x's. And both those x's are going to get replaced with x plus h. I have x plus h minus 4. And then I have x plus h down below here. You actually don't have to even worry about simplifying that. The only thing you could do is multiply the 2, but then you're not going to have like terms anyway. And so it's okay to leave your answer in this form. There's no like terms on top or bottom. We're not allowed to divide the 4 by the 2 here because you got plus and minus signs that are separating all that. So you're not allowed to cross reduce anything in this case. So that would be as far as you can go with your answer for part B. Next says, so here's our original, the same one again. We want to find f of x plus f of 5. Okay, so f of x we have here, and then plus f of 5. Well, f of x is just the original equation that we are given here. So x minus 4 over 2x minus 3. Then there's a plus, and then I want to grab my answer for f of 5 that I did above over here. F of 5 was 1/7. So let's put in 1/7 right here. All right, and then that's really about all you have to do there. It doesn't give us any special instructions to do any more, and so we can leave our answer in that. Now in the notes that I have, in the written notes that's available, I did go ahead and get common denominators with that, so you can review that if you want to, but it's not necessary here because it didn't give us any specific instructions to do so. So because of that, we can just leave our answer as 2 separate fractions. And in the homework, they don't really ask you to do that either. They're not going to ask you to get common denominators. So D and E, we have these last two here that have the f of negative x and negative f of x. So we got those kind of things again. All right, so for this one, f of negative x just means that you're going to put in a negative x in there, all the places where you see an x. So negative x minus 4. At the bottom, I have 2 times negative x minus 3. And if you want to do one more simplifying step, we can do that here. Negative x minus 4. And I have negative 2x minus 3. And that's it. So that's all you can do on that. Again, we don't know what x is, so we can't get a numerical answer. Just replacing all the x's with negative x. We have that. Then we have one more here. We want to find negative f of x. Okay, so for this, when we do that kind of problem, what this means, I have negative f of x. This is just equal to negative 1 times f of x. And so we're going to do negative 1 times this right here, just like that. Now, for this, okay, what this really means that you have is that with negative 1, you're not doing negative 1 on the top and negative 1 on the bottom. Okay, that's important to note because remember, the number negative 1 is not equal to negative 1 over negative 1. Negative 1 over negative 1 is actually positive 1. So in fact, when you have with that one here, you're just multiplying negative 1 across the top only. So if you want to distribute that, you can. But remember, negative 1 only goes across the top, not the bottom, because you're multiplying by really negative 1 over 1. You could also multiply, make the top number positive and then the bottom number negative. You could do that as well. But only one of these, either the top or the bottom, gets multiplied by a negative. If I leave it the way I have it written out, just like this, then that would be negative x plus 4 over 2x minus 3. Or I could also write that as 4 minus x. That's okay as well. But that's the main thing there, is just this. Now, you could also, if you wanted to, you could also just simply do this, and my open math would take this as an answer as well. You could just leave the negative out front of everything. So just put a negative and then enter in your fraction. That's also acceptable as well. So all of these, this one and this one, both, either one of those would be considered correct, and it would mark it correct in my open math. So those are all, either one of these would be fine. Okay. The next thing we're going to be moving on to, so though I kind of covered a couple problems where you have to enter a whole bunch of information or evaluate it all on different things. It's a multi-part problem, and you'll see that also in the homework that it's a multi-part problem when you see those. The next couple of problems that we're going to be getting into are ones where you're finding the domain. Now, we did talk about domain at the beginning of this section. Okay, so we talked about domain before. Domain is talking about all the values for x that make the function defined. In other words, you're looking for all the values of x that don't cause division by 0 or square root of a negative number. Okay, so that's what we're trying to find here. When you write your answers on these, you're writing your answers actually in interval notation. So interval notation, if you're not sure what that is, it's basically the type of thing where we're using parentheses and brackets to indicate our answer. And so we'll do a couple of these and we'll kind of review the interval notation as we go on with that. So we got here's the first two that we're going to take a look at here. We've got the domain of each of these. Now, when we do these problems for domain, if the problem does not have division by 0 and there's no chance of you taking the square root of a negative number, if there's no square roots in the problem, there's no fractions in the problem, then what you're going to put is you're going to put all reals for your answer here. So your answer for this is going to be negative infinity to infinity, and that's going to be your answer on that one. So negative infinity to infinity, that means that all real numbers, that means there's nothing we can put in here that's going to cause division by 0 or square root of a negative number. So essentially, I can put any x value in here I want, and this is going to use all the x values from negative infinity to positive infinity. In fact, excuse me, the same thing happens on the second one. Okay, I have a square that's here, but there's no chance of me taking the square root of a negative number or dividing by 0, because whatever value I put in for x, none of that's going to happen. I can put any value for x that I want, and I'm always going to get a value out for y. So that's another one where my answer is going to be all real numbers, negative infinity to positive infinity. But we're going to continue with, now this next one here these next two problems we'll look at, these do have some things we have to be careful about, because for this one, we have a fraction. So it is possible that if I put a number in for x, I could have division by 0. So whatever number causes division by 0, that number is not allowed in my domain. So essentially what that's saying is that the 2x minus 5, that cannot be equal to 0. I cannot have a 0 in the denominator, because if I did, that means I have division by 0. So your domain is talking about all the numbers that do not cause division by 0. So therefore, by solving this equation, that's going to tell me what number I'm not allowed to include in my domain. So I'm going to add 5 to both sides. I get 2x is not equal to 5, divide by 2. And what I come up with here is it says that x is not equal to 5/2. That means that any other number I put in here is fine. I just can't have 5/2, because if I put 5/2 down here, I get 0, and I can't have division by 0. So I want to write the interval notation that includes all the numbers except for 5/2. Now, if you want to look at this on a number line, no, you don't have to do a number line on these kind of problems here. But what I would have is I have a number line that includes everything except for 5/2. Okay, so that's basically what I'm saying here. All the other numbers are fine, except the number 5/2 itself cannot include that in my domain. So the way that we're going to write this interval notation is we're going to include all the numbers before 5/2 and all the numbers after 5/2. All the numbers before 5/2, that's going to go down to negative infinity. So I have negative infinity to 5/2 with a parenthesis. I have to put a union symbol. The union means or. So my x values can either be before 5/2 or it can be after 5/2. So now I want to include the interval notation that comes after 5/2. When we use parentheses, parentheses means that the number is not included. If we use a bracket means the number is included. Okay, so in this case, I want to use parentheses because I do not want to include 5/2. So this is saying that my domain is going to be all the numbers less than 5/2 and all the numbers greater than 5/2. But the number 5/2 itself is not included because that causes division by 0. That's how you do that one. For this one down below here, we have a square root. And what we know about square roots is that we can't take the square root of a negative number. So whatever is inside the square root has to be positive. So this is how you're going to set this up if you have a square root. You're going to put 2x minus 5, which is what I have inside. That has to be greater than or equal to 0. Whatever is inside here, if I solve this equation, that's going to tell me all the values that I'm allowed to put inside here. I am allowed to take the square root of 0. I just can't take the square root of anything that's less than 0. Okay, so as long as I have a number that is greater than or equal to 0, that'll work inside here. So let's solve this equation. I get 2x is greater than or equal to 5, divide by 2. And I get that x is greater than or equal to 5/2. So this is telling me that any number that is larger than 5/2 or equal to 5/2 will work in here. I don't have this. This is not on the bottom of a fraction or anything like that. I just have a square root only. And this is how we solve it. So when you do interval notation, if you have these symbols, the greater than or less than symbol, you want to use parentheses. And if you have these symbols, that means you're going to use brackets. Okay, so the equal sign underneath means that we do want to include that number. And so that's why we have the bracket there. If you have greater than or less than, you're just going to use parentheses. Okay, so here we have a greater than or equal to. That means that as a number line, it would look like this. Okay, so I have 5/2 is included, and then I'm including all the numbers after 5/2 there. So as an interval, I'm going to put a bracket at 5/2, and that's going to go to infinity, just like that. Okay, so 5/2 to infinity. 5/2 is included this time, and I'm including all the numbers greater than 5/2. So that goes to positive infinity there. That's my answer on that. Suppose we have a problem that combines both of these things together into one. So that's the next domain problem that I'm going to do. I'm going to do one that has a fraction, and it also has a radical in the bottom. So I'm going to do two different ones that have a radical in the bottom. Okay. Now, for this one here, for square roots, first of all, I know that whatever's inside here cannot be negative. But also at the same time, this cannot be equal to 0 on the bottom. So what I did in the last problem was when I had just a square root by itself, I used greater than or equal to. The difference I'm going to do on this problem is I'm going to take 2x minus 5, and I'm going to set it to be just greater than 0 only. Okay, so greater than 0. Notice that I don't have for this, I do not have an equal sign underneath. And the reason why is because I don't want this to equal 0, because then I have division by 0 happening there. I always want to avoid division by 0, and I want to avoid the possibility of taking a square root of a negative number. So as long as I have 2x minus 5 is greater than 0 like that, that's going to be the right setup. So if you have a square root that is on the top of a fraction, or if you have a square root that's by itself, you're going to use the greater than or equal to symbol. A square root that's by itself, or if it's on the top of a fraction, you're going to use the greater than or equal to symbol. If the square root is on the bottom of a fraction, then you're going to use the greater than symbol. You're not going to use the equal sign underneath. Because the radical is on the bottom of a fraction, you're going to use a greater than. Now, this only applies, I should mention this rule that I said here, that only applies to even number roots, like square root or fourth root or sixth root, something like that. That's where this rule applies. If you have a cube root, like this next example we're going to take a look at in a minute here, that's different. Okay, so if it's a cube root or a fifth root, if it's an odd root of something like that, an odd root, that means that that's going to be done a different process, so we don't have to actually use the inequality symbol at all. So problem like this and like this, where we have a greater than symbol, that's only if you've got a even number root on that one. All right, so this one here, we're going to do an even number root. So we're going to put, for that one here, solve for it. 2x is greater than 5, divide by 2. X is greater than 5/2. So this means that it's going to be almost the same as the answer we had up here, except that instead of a bracket, the difference is we're going to have a parenthesis instead. So parenthesis 5/2, comma, infinity. All right, so if you have a greater than symbol, we got to use a parenthesis on that. So it's greater than, so it's going to go from 5/2 all the way up to infinity. For this one here, we have a cube root. So we don't need to worry about putting a inequality symbol. Now, the reason why is because we can take the cube root of a negative number. For instance, let's just do this off to the side. If I had the cube root of -8, that would be equal to -2. So I am able to take an odd root of a negative number. That's possible for me to do. So negative numbers are allowed down below. So I don't have to worry about using a greater than symbol like I did previously because it's an odd root. Now, whatever number is inside the root, I have to make sure I don't divide by 0. So x minus 3 cannot be equal to 0 in this case because the cube root of 0 would be 0. So if you have a cube root or a fifth root like that, then you're just going to be working with just make sure you don't have it division by 0. Okay, so that means that x is not equal to 3. And then I'm going to put the interval notation. Remember that this really means that we have a 3 here. Everything before the 3 is okay. Everything after the 3 is okay, but the 3 itself is not included. That's going to look like this: negative infinity to 3, a union, and then from 3 to infinity. It's basically all numbers not including 3, and that's going to be my answer that I have on that one. Okay. So a question that often comes up is, if I have a fraction, does that mean every single time I'll have a number that's not included? Well, not always. So let's take a look at this case here. I have 1 over x squared plus 9. Now, x squared plus 9, that's not a difference of squares, so I can't factor this in any kind of way. And what I want to take a look at is try and see if I can solve and see if there's any number that will cause this to be a 0. So I'm going to take x squared plus 9. And what I'm going to do is, I know that x squared plus 9 cannot be equal to 0. So I want to try and solve this. If I can solve this, that means those are numbers that are not included in my domain. So I have this. I'm going to subtract the 9 to the other side. And I get x squared is not equal to negative 9. And if I take the square root of that, we get plus or minus the square root of negative 9. Now this number right here, this is actually considered to be imaginary. Okay, that's not a real number there. The square root of a negative number we can't do. That's impossible to do there. That's not a real number. So therefore, the only way that this bottom part's going to be a 0 is if I have an imaginary number inside there. Well, imaginary numbers we don't want to include anyway. So what this is saying is that there are no real numbers that cause division by 0. That's basically what that says. No real numbers. Actually, I don't even need the dat here. No real numbers cause division by 0. Because of that, that means that my domain is going to be negative infinity to positive infinity. If there's no real number that ever causes division by 0, that means that it's going to work for any number I put in here, and there's no restrictions on my domain. My domain is negative infinity to positive infinity. Now, what you might be thinking is, well, wait a minute, what about negative 3? If I put negative 3 and I square negative 3, won't that give me negative 9? And I get negative 9 plus 9 will give me a 0. Okay, so that one you got to be careful about here. If I put in negative 3, remember that the negative 3 is the one that's being squared. I don't have negative on the outside. So if I try and put negative 3 in here, negative 3 squared is actually going to give me a 9. And so I don't get division by 0 in that case. So both negative 3 and 3, if you square them, you're going to get positive 9. So that's why negative 3 doesn't work. If you might have been wondering why the answer is not negative 3, it's because negative 3 does not cause division by 0, and therefore negative 3 can be included in my domain. So that means there's nothing that causes division by 0. So my domain is negative infinity to positive infinity that I have there. Okay, I'm going to do 2 more questions. I'm going to do this one, but then I'm also going to do another one over here. I'm going to do another problem. Find domain of, let's just do f of x equals x plus 7 over x squared minus 121. So I'm going to do that example as well, because there's two different types that we have here, just to make sure I cover everything that the homework has in there as far as domain is concerned. Okay, let's do this one right here, find the domain. Now I have two different situations, two different things happening here. First of all, I have a square root on top. Okay, so square root means that, so let's deal with the square root first. Okay, so for that, I have x minus 3 is greater than or equal to 0. Notice that the square root is on the top of a fraction. So if the square root is on the top of the fraction, you're going to use the greater than or equal to symbol. If the square root is on the bottom of the fraction, you're just going to use the greater than symbol. Okay, so greater than or equal to, I want to use on this. Okay, so if I add 3 to both sides, I get x is greater than or equal to 3. And I'm going to stop there. I'm not going to put the interval notation in just yet, because I also want to consider the bottom one as well. So for the bottom one, I have x minus 6, and I know that the x minus 6 cannot be equal to 0 down there, because that would cause division by 0. So I'm going to add 6 to both sides, and I get x is not equal to 6. I'm going to definitely, for this one, it's probably better to do a number line so you can see visually what's going on. First of all, I have here that at 6, there's an open circle. So that takes care of the bottom one. Also, I have that a 3. So I'll put a 3 here. X is greater than 3 means I have everything going to the right. So this is what my interval notation is going to look like. So I have x is greater than 3, but at the same time, x cannot be equal to 6. So this is what my interval notation would look like. Now I want to include it. My answer is going to have everything combined together. So because I have two separate pieces, I need to include two different intervals on this one. Now the dark circle, I'm going to use a bracket because 3 is included because I have the equal sign here. That's going to go up to 6. I'm going to put a parenthesis there because we don't want to include the 6. And then I'm going to include 6 to infinity after that. So I have everything from 3 to 6 is included, and then from 6 to infinity is included, but 6 itself is not going to be included. And that would end up being your domain for this one. That's probably one of the harder ones because that includes both things at once that you have to consider. So again, because this was on the top, that's why I have the greater than or equal to symbol there. So x is greater than or equal to 3. And on the bottom, I can't have 6 because then I have division by 0. So that includes both of them combined together. And that's why I drew the number line so we can see visually what's going on. We are including all the numbers greater than 3 except for 6. That's basically what that's saying. Now I want to do one more. Okay, so one more, and then that way we'll kind of cover all the different domain type questions. So I've tried to do a bunch of different kinds of examples for you to show you all different kinds of possible problems that you'll see in the homework, and so that way you'll know how to answer something like that. All right, so now here's the last one we're going to do. Okay, so this one I didn't originally have type out, but I want to go ahead and show an example anyway, since it is one of the problems that's in the homework. For a problem like this, again, the bottom, we don't have any square roots to deal with. We just have the bottom. This here, x squared minus 121, that one cannot be equal to 0. Okay, so I'm going to solve this. Now I can solve that by bringing the 121 over the other side. So I have x is not equal to 121. And then I'm going to take the square root of both sides. So if I take the square root of both sides, I get that x is not equal to plus or minus 11. Okay, so plus 11 and minus 11, I'm not including in this case. Okay, so as for a number line, I'll just put a number line right here. I have actually two open circles, one at negative 11 and one at 11. So everything before 11, I'm including. Everything between negative 11 and 11, I'm including. And everything after 11, I'm including. So that's what the number line would look like here. Notice that I have 3 different shaded regions here, which means that when I write my answer, I actually am going to include 3 different intervals for my answer on here. So I'm at the domain I'm going to write at the bottom down here. I have negative infinity to negative 11, or I have between negative 11 and 11, or I have from 11 to infinity. That bottom line there, that's what I would put in for my domain. So we have to include all that. So this is one where you're actually going to have 3 different intervals. That's why I wanted to cover this one. So that way you understand there's 3 different intervals here. One for the less than negative 11, between negative 11 and 11, and another one greater than 11. That's going to be all 3. So that was one more example I wanted to show you there for this. So we have all of that. Okay. All right. So that's all the. So I did try to do several examples because there's a lot of problems in here where it's asking to find domains. You should be able to answer those questions. Now this last piece, I'm just going to go ahead and introduce it, and I'm going to show one problem, but then we'll do the rest of them later because we don't have time to cover this whole section. So again, 2.1 will not be due until next Sunday, okay, a week from Sunday. Okay, so here's the basic idea with difference quotient. Difference quotient is basically we know how to find slope of a straight line. However, we're starting to get into some situation where we might have a curved line here. So this here, we're just going to call this curved line f of x. And we're going to find 2 different points on there. I'm going to write those coordinates here. So this is going to be x, and f of x would be that coordinate right there. And this coordinate right here, we're calling b. That's going to be x plus h, and then f of x plus h. So I'm putting f of x is the original equation I had. That's why you put f of x in for x, you'll put that inside the parentheses here. Now what I want to do is I basically want to take these 2 points and I want to find the slope between those. And here's the 2 points that I have right here. I have x and f of x. I have x plus h and f of x plus h. If I call this x1, y1, x2, y2, I could actually put it into the slope formula, y2 minus y1 over x2 minus x1. I could put it into that slope formula, and if you do that, you're going to get this equation down below. If I have y2 minus y1, that's f of x plus h minus f of x. I have on top. On the bottom, I have x2 minus x1. Well, if I have x plus h and I subtract x from it, that's just going to give me an h on the bottom. So what I'm doing here is finding an expression that allows me to find the slope of something if I only have 2 points. Now, this actually is something that you're going to do for those of you going on to Calculus 1. So Math 181, you are going to definitely see this again. This is actually a little bit of calculus is what we're actually doing. Now, calculus, you're going to go beyond finding the difference quotient. So you're going to find this expression, and then you're going to do something else to it in calculus that we're not going to cover here. All we're going to cover is finding the difference quotient by plugging things into here and simplifying it to get the answer. I'm going to show you this example that we're going to end today with this example here. I want to do this one all the way through. I'm going to use this difference quotient formula and this f of x, and I'm going to find the answer on this one. So I want to find f of x plus h minus f of x all over h. This is what I want to find ultimately. Now to do this, what I'm going to do is I'm going to substitute some things into this formula. First of all, f of x is just the original equation that they give us here, which is 2x minus 3. So I'm going to remove the f of x, replace it with 2x minus 3. Notice that I'm putting parentheses around here because the minus sign means I'm distributing all the way through there. So that's why I have to put these parentheses there. Now up front, I need to find f of x plus h. Now we were doing these at the beginning of this section. We were talking about doing some problems that are similar to this. Now the way that you do that is we have 2 times a blank and minus 3. So this is the original equation without the x in it. So what I did was I took out the x. I'm going to replace it with x plus h. So this is how I'm going to substitute everything all in there. This is my f of x plus h, that part. We have a minus, and then this is our f of x part that we have. So now we're going to simplify all this or multiply all that out. So 2x plus 2h minus 3. And I have minus 2x plus 3 here. All that's going to be over h. Okay, so I did just a distributing step all the way through there. And now I want to simplify what I have. I have like terms that I'm going to be able to simplify on that. So the 2x and the negative 2x, that cancels out. I have the negative 3 and the 3. Those are going to cancel all out. So what I end up with here is 2h over h, which is equal to 2, because we can cancel out the h's. So the difference quotient I found here was 2. Now that makes sense, because remember what we talked about before, the difference quotient is nothing more than a slope. Now, typically we're going to use difference quotient to find the slope of curved lines. So in this case here, we don't even really need to use difference quotient to find the slope, because I just could have looked at the number in front of the x and just said, okay, that's the slope, the number in front of the x. However, the problems that we'll be doing for next week when we come back is problems that are quadratic or something like that, to where the difference quotient is going to end up being an expression instead of an actual number. Because this is a line itself, that means that we have for this one, that means that we get exactly what to be expected. We got the number that was in front of the x there. So, but that's going to be it for now. We're going to stop at that point, and then if everybody has any questions, you can ask those now. We didn't finish all of 2.1, but with these notes that I gave you, if you finish up with 1.1 through 1.4 and you want to work ahead, you do have that ability, because you should be able to do problems like 1 through 17 in your homework, because we actually covered almost everything. The ones that you won't be able to do just yet are probably the last 3 questions have to do with difference quotient. And so you can kind of wait on those. But if you'd like to work ahead, you can definitely start working on section 2.1, since it is open now for you to start. So with that, I'll kind of stop. Does anybody have any questions now to ask over anything we did for today? Any questions anybody has? All right, so I do answer emails over the weekend. So please feel free to send me any questions that you might have. So I'm going to go ahead and end this meeting. Enjoy your weekend. I'll see you back on Monday.